In this video, we're going to take a look at the three basic trigonometric ratios and what trigonometry is anyway. Trigonometry is basically a branch of mathematics or subset of mathematics that looks at the study of right triangles and triangles in general. And essentially what we're going to do is use known ratios, so comparisons of things, to find maybe missing sides or missing angles of known triangles. Now, the foundation of trigonometry are the three main trig functions: the sine, the cosine, and the tangent. And for our purposes, we're going to use the letter theta, so this is the Greek letter right here, theta, to denote an angle. Okay? So these three trig ratios that are given to us, sine, cosine, and tangent, are the foundation of all of trigonometry. And the sine is defined as the ratio of the opposite side to the hypotenuse. The cosine is defined as the adjacent side compared to the hypotenuse. And the tangent of an angle is defined as the opposite side compared to the adjacent side. One of the most important things we have to make sure that we do correctly is label the sides opposite, adjacent, and hypotenuse based on a particular angle. So we're going to look at a little sketch to make sure we know how to do that. And here we have a sketch with two right triangles, actually. Triangle AB, and then we'll call this C down here, and A prime, B prime, C prime. So they're the same triangles but different sizes. So I want to show angle A. And if we're talking about angle A down here, it's this guy labeled right there. And the opposite leg is going to be this one here. It's the one across from angle A. Basically, it doesn't touch where the angle part is itself. It's just going straight across. There's our opposite side. And then we have our adjacent side, which is this next one. This side right here is always going to be the hypotenuse because it's across from the right angle. If we do the same thing for B, you'll notice that when I show the opposite leg, now it's this one. And the adjacent leg is now this one. So because I've changed my angle, I've changed the location of the opposite side versus my adjacent side. So let's put this into practice. So for angle A, we're going to label the opposite side, adjacent side, and hypotenuse. So I'm going to circle this angle right here. And if I'm looking at angle A, if I go straight across, that's my opposite side. Identifying the right angle, going straight across from that, that's my hypotenuse. And then my other side here would be my adjacent. Now if I'm going to do the same thing for the second triangle, now we're at B. It's the same triangle, but now we're looking at a different angle. Going from B, if I go straight across, this is my opposite side. Across from the right angle is my hypotenuse. And here we have the leftover side, which is our adjacent. So let's go ahead and do this. So if we have angle A, we're going to find the sine, the cosine, and the tangent. Then we're going to compare what happens when we have the sine of B, cosine of B, and tangent of B. Circling angle A, I'm going to do this one in red, labeling my sides. This is my hypotenuse, this is my opposite side, and this is my adjacent side. And so the sine, the opposite side, is 5, and the hypotenuse is 13. So the sine of A is 5 over 13. And the cosine of A is the adjacent side divided by hypotenuse, so it's 12 over 13. And the tangent is the opposite side over the adjacent, so 5 over 12. But for angle B, this is now the opposite side, this is now the adjacent side, and the hypotenuse has not changed. It's still the same thing. So finding the sine of angle B, we go across from angle B, we get 12, and our hypotenuse is 13. The cosine of B, the adjacent side is 5, the hypotenuse is 13. And for the tangent, it's the opposite side, which is 12, divided by adjacent side, which is 5. Now you might have noticed that there's some kind of unique relationship about these. If I'm in the same right triangle, and I switch my angles, it appears that the sine and the cosine values are going to flip-flop. So the sine of A is the cosine of B, and the cosine of A is the sine of B. The tangent, we find the reciprocal of it. So we had 5 over 12, now it becomes 12 over 5. So the relationship is that the sine and cosine, and I'm going to just, like, I don't know, put it this way, switch, because they are. Cosine of A is now the sine of B. The cosine of, or sine of A is now the cosine of B. And the tangent, we find the reciprocal. Let's flip the fraction. Now what about one like this? So the sine of theta, cosine theta, and tangent of theta. So we have the opposite side, the adjacent side, hypotenuse. So the sine of theta is 3 over 5. The cosine of theta is 4 over 5. And the tangent is 3 over 4. Easy enough. Why are we talking about this one? Let's look at the next one. We have this angle theta. Our opposite side is 6. Our adjacent side is 8. Our hypotenuse is 10. So the sine is the opposite side over hypotenuse, which is 10. And if I reduce that down, I get 3 over 5. Interesting. When I do the cosine, I get the 8 over 10, the adjacent side over hypotenuse. And when I reduce that, I get 4 over 5. Huh. And when I do the tangent of theta, I get my opposite side, which is 6, over my adjacent side, which is 8, and I get 3/4. Wait a minute. I had those same measurements in this triangle. This was a 3, 4, 5 triangle, and this is a 6, 8, 10. Why are they going to give me the same reduced ratios? Happens to be because these triangles are similar, so the ratio of the sides is always exactly the same. So the corresponding values are equal because the triangles are similar. So then our last couple questions here, I want to focus in on these right now. Can the sine of an angle ever be larger than 1? Now, the sine of theta is always my opposite side over the hypotenuse. I don't think that it can ever be larger than 1 because I know for a fact that the hypotenuse is always the largest side of a right triangle. So no, because hypotenuse is the biggest side. All right. 13 says, can the cosine of an angle ever be larger than 1? So if I do the same thing, no, because again, the hypotenuse is always the biggest side. But the tangent is the opposite over the adjacent. Now, I don't know for a fact that the adjacent side is going to be the biggest side. I don't know that the opposite side is going to be the biggest side. So yes, when opposite side is bigger than adjacent. So again, the sine is the ratio of the opposite side compared to the hypotenuse. The cosine is the ratio of the adjacent side compared to the hypotenuse. And the tangent is the ratio of the opposite side compared to the adjacent.